Back to Further Solutions Academy. I think I've started earlier, the definition of eigenvalue and eigenvector. Don't forget to share our videos, subscribe if you have not subscribed before. Kindly press the subscribe button. On this video, I'll be walking you on an example on eigenvalue and eigenvector. I have to combine it together. Normally, I'm supposed to do it different after I will work on the characteristics equation. I think you need to understand what is called characteristics equation. You know what is called there are things we need to understand at this point, but let's see as we move. Let's see what will happen. I will start from 2 by 2 matrix, which is finding the eigenvalue and the eigenvector of 2 by 2 matrix. Now, for instance, I have a problem here. Look at this question. The question says if A equals to 3, if A equals to 7, 3, and okay, and that to find the eigenvalue and eigenvector. Now you have to find the eigenvalue and eigenvector. Now, you have to explain many things anyway. For your information, there are different ways of looking for eigenvalue. I've told you earlier that our eigen is always equals to my A of U of V equals to lambda of V. This is vector, while this one is what? Eigenvalue, which I've explained earlier. And I've said that eigenvalue, eigen means is a word from German, which means owns value. Don't forget that, owns value. And eigenvector also, which I can reverse this by having V minus lambda of equals to 0, which I can also say that A minus lambda, bracket of what? V, now equals to 0. Now, by so doing this, I will move on and I will generate my characteristics equation and other things that I need to find here. Now, when I have something like this, the first thing you need to understand is very simple. Just know that it's very, very simple. The first thing you need to understand is that let's try to solve it. Let's see how it will go. Now, the first thing I will find, don't forget my A equals to what? 7, 3, 3 minus 1. Now, I will teach it as if I'm, for elementary, but the next time I will be using trace to generate my characteristic equation, trace and the row reduction of the principal diagonal with the determinant, which I think that's very soon you understand that. Let's see what will happen here. Now, what I need to do now is that I will generate a lambda of U equals to what? Lambda U. Now, which I will be having U, AU minus lambda U equals to 0, which I will be having A minus lambda U bracket of U equals to 0. Now, take note of this thing. This is the vector. These are the what? Now, what is my A? My A, to write it very well, I must have it in minus what? Lambda I. Because this is a scalar. And we know what I means. I means what? Identity matrix. That is very, very important. Now, which I will now say that my A minus lambda I equals to 0. Now, let me try. This is called, now, with what I'm going to do now, I'll be having, what is my A? 7, 3, 3 minus 1 minus, that is my lambda I have it what? I have lambda minus, lambda is 0 lambda. Please take note of that, which is to be equals to, that's what I'm going to find here. Now, there are many ways of finding something like this. Let me try to generate one for you. The first thing I will just need to do, let me please take note of this. Note this information. It's very, very important. Now, how do I go? I can say that my lambda is power 2 minus trace of what? Trace of principal diagonal, which is trace. You know what is called trace? Which trace will be what? Trace of lambda raised to power what? Okay, trace of the A, which is lambda minus what? Plus what? The determinant of that A. That is how we need to do. Now, what does that mean there? I will find the trace. What is going to be the, I have lambda raised to power 2 minus, what is my trace? My trace will be minus 6. I will add the principal diagonal together, which I will have 6. That will be minus 6 lambda. Now, what is the determinant of this given matrix? This times this, I have minus 3. That is going to be minus 9. Minus 3 minus 9 will give me minus 7 minus 9 will give me minus 16. Now I will be having minus 16 because this is plus, which is going to be minus 16. Minus 16 equals to 0. Now that is this easiest way of finding determinant. But most of our professor or our this thing we try to show something like this and find determinants by having minus lambda 3 and 3 and minus 1 minus lambda. Now this will now form your. Now we don't need to go with this. Don't need to go along with this, which I'll be having 7 minus lambda, bracket of minus 1 minus lambda, and minus 9, which is now when you do the same thing, which I will be having 7 over minus 1 minus lambda, and we have minus lambda bracket of minus 1 minus lambda minus 3 equals to 0. This will be minus 7. This will be minus 7 lambda. This is going to be plus lambda and plus lambda squared minus 7 equals to 0. Now, can you see that I have my lambda squared? I have this and this become minus 6 lambda, and this and this become what? Minus 16 equals to 0. Can you see with the help of my what? Don't forget my. If it is 2 by 2, you have it power 2. If it is 3 by 3, I think I will, as time move on, I will keep moving on that level. You don't need to be stressing yourself on generating your. Now, take note of this. This is known as Crasteriti's equation. Please take note of that. That is known as Crasteriti's equation. This is called Crasteriti's equation. And from here, we generate our what? The factor of the given variable, which is that I will be having. Please permit me to rub this part because I don't need to be. I have to show how it's being done. That is. It's good to know that. Now, since I know that, I will now generate the factor of this this equation. How do I generate the factor of the given equation? I will turn it to quadratic equation. What can I multiply to get 16? And the same number will be added to get minus 6 minus 16. I think I will be working on 8 times 2, which is going to be giving to give me lambda squared. I'll be having plus 2 lambda minus 8 lambda minus 16 equals to 0. I'm just on quadratic equation. This will give me, I'm grouping into 2, which I will have lambda power plus 2 minus 8 lambda plus 2 equals to 0. Lambda equals to minus 2 or lambda equals to 8, which is, now this is called eigenvalues. Please take note of that. This is called eigenvalues. Take note of that very well. Now, I will now generate from the each eigenvalue. I will now generate corresponding eigenvector. Now, to get my eigenvector, don't forget, I call this one Crasteriti's equation. I call this one eigenvalues. Please take note of that very well. Crasteriti's equation and what? Equation and eigenvalue. Now, how do I generate my eigenvector? Now, I will come back to this place, which is where I have my what? My lambda minus, 7 minus lambda. I have 3. I have 3, and I have minus 1 minus lambda, which is going to be what? I will be having x1, x2 equals to 0. Now, from what is here now, that is my, now notice that when my lambda equals to minus 2, now what will I do? It means I'll be having 9, which is my lambda is minus 2, I'll be having 3, I'll be having 3, and minus 2, which is going to be, it will be 1, yes, plus 2, minus 1 plus 2, that will be 1, I'll be having x, which is going to be 1 and 2, which is going to be what? Is 0, 0. Now, with what I'm having here, I can now move on by having the next thing I need to do. I need to generate this thing, which I will try to augment it. You know what's called augmentary matrix, which I'll be having A3, 3, 1, and I have to augment it 0, 0, which is I'm used to Gaussian elimination method. Please take note of that. I'm trying to use that now, which I will do whatever I want to do, which I will try to get that this, which will be, I will divide row by row 1, and this will remain the way it is, which it will be reduced to what? I have 3, I have 1, and I have 3, I have 1, and 0, 0. Okay, now I'm trying to reduce now, which I can say that what my row 2 equals to row 2 minus row 1, which I'll be having 3, 1 is 0 is 0, augment it. Now, this will take me to what is called normalization. I will normalize it just because of what 0 is present here, which I will be having 3x1 plus x2 equals to 0. Now, it means I will be talking about what? My x1 equals to minus x2. Please take note of that. Now, it means my x1 equals to minus 1, my x2 equals to 3. Now, since what I'm having here, I'll be having x1, x2, which it will be directly equals to what? Minus 1, 3, which will be. Now, this will take me to minus c and 3c. I need to what? Normalize it. Now, what make me to normalize? Because I have non-value, this here. Now, which I will be talking about with what I'm having now, I want to normalize, which you know what is called normalization. I will have minus squared plus 3 squared equals to what? 1. That is what is called normalization. Now, which I'll be having c plus 9c equals to 1. 1 squared is going to be, and which is going to be squared. I'll be having 10c equals to 1. My c squared equals to 1 all over 10. My c 1 all over root of 10. Now, I will now come back here, which I will be having x1, x2 equals to, now I'll be having, what is my c, which I'll be having minus 1 all over root of 10, and I'll be having 3 all over root of 10. That is my vector. Now, that is when my lambda equals to what? 2. Now, I will do the same thing for what? When my lambda equals, permit me to rub this part, I have to rub this part very well. Now, when my lambda equals to 1, when my lambda equals to 8, I will do the same thing. What will I do? It means I'll be having 7 minus 8, 3, 3, minus 1 minus 8. And we have x1, x2, which is equals to, now, which it will be 0, 0. Sorry, we're talking about 0. Now, which what I'm having here, this one will give me 1, minus 1. This is going to be 3, this one will be 3, and this one will be minus 9. x1, x2, and 0. I will try to do augment. There are different ways of solving this. I think try to be with us. There are different ways. You can use any method of your choice. Now I can say that 3 and 3 minus 3. Now augment it. What I will do is 1 all over 3 of root 2 equals to, I think I will be having minus 1, 3, 1, minus 1. Minus 3 rather. 0, 0, and now also if I subtract this by this, I'll be having minus 1, 3. This one will be 0. I will add this to this. 0 is 0, which I will have the augment and augment. Now, with what I'm having here, allow me to use this method. This space to manipulate this. Now, with what I'm having here, I can now say that. Now, it means I will be talking about, I will need to normalize it also. Minus x1 plus 3x2 equals to 0. Now it means minus 1 minus x1 equals to minus 3x2. Now it means my x1 equals to 1, my x2 equals to 3. That is the interpretation. Now, since I have this, I need to normalize it again because of what? I have this particular rubbish here. Now, what will I do? How will I normalize? I think I will be saying f1, s2 of this equals to, I have my 1 and 3, which is, it means this is linear mapping. I think the linear transformation, I've talked about it yesterday, before now, which I will be having, which I will be moving on to C, please take note of that. I'll be having C squared plus 3C all squared equals to 1. I'm trying to normalize, which I will be having 9, which will be what? C equals to 1 all over root of 10. That's the same thing as this. Now, it means my x1, when lambda equals to 8, I think I'll be having my x1, my vector, which is my vector, will be equals to it will be equal, okay, it means it will be equal 1 all over root of 10 and 3 all over root of 10. Okay, that is it. It means when lambda is equals to, this is when lambda is equals to minus 2, when lambda equals to minus 2. Please, that is all about that. I think you can see it's very, very simple. With what is on ground, I think you should not have problem with it. Before I continue, okay, let me try to show one more example. In this case, it will be on 3 by 3 matrix, which is 3 by 3 square matrix. Now, okay, look at this problem. Okay, look at this problem. There's another question that somebody can ask us, but different between this and then, and before now, this one is 3 by 3 vector matrix, and the scalar is being declared, which is the eigenvalue is being declared. Now, it means there are 3 eigenvalues there because I've told you earlier that for me to find my analysis equation, don't forget that this one will be 3 and minus trace of a lambda squared plus, this one will now be plus, minus, what's the name of this thing? Cofactor of a principal, please diagonal, please take note of that, principal diagonal of what? Of that, which is going to be what? Of A, which is going to be lambda plus what? Determinant of that A equals to 0. Please, this is how you need to go with what I've done earlier. What I need to do, if this is not declared, now I want to get there will be 3 eigenvalues. There will be 3 eigenvalues because this particular equation, it will castrate polynomial of degree 3. Now, this is how to generate a what? Now, with what is on ground now, I can easily find my what? My eigenvalues, castrating equation by having this. This is my trace. This is called trace. Think of that. This is called trace. For those that don't understand. Now, in the cofactor of the principal diagonal, now this is a cofactor. I will just derive this. I will terminate of this, and I will get it plus, and so on and so forth. I think I will cite an example for better understanding for those that are not very that cannot get it like that, because we have to teach on this channel just to understand mathematics and other problems. Okay, now I want to do this. I don't need to stress myself. Solution to this problem. I'm just trying to illustrate them. Now, when I have something like this, my lambda, don't forget, it is always like this. 11, which is, let me state it very well. A minus lambda of what? Of V equals to what? 0. This is what we are talking about. Now, there's no way I will work on this without what? Please take note that there will be I here. It means indirectly, I'm talking about what? What is my A? 11 minus 11 minus 7 and 7 minus 7 minus 5 and 3 minus 3 and minus 1 minus, what will be my lambda? High will be lambda is 0 is 0, 0 lambda is 0, 0 is 0 lambda. That is what I'm talking about here. Now, which is will be equals to 0, don't forget, it will be equals to 0. By so doing this, I will be having, I don't need to stress myself, since my lambda is declared as 2, it means I'll be having 2, I'll be having 2, I'll be having 2, which is very, very straightforward. Now, this minus this, I'll be having 9, and this minus, I think my level remains the same, my 7 remains the same. I have 7, this and this will be what? Minus 9, and this will remain my minus 5, this remain 3, this remain minus 3, and this remain minus 3. Now, can you see? That is what I'm talking about. Now, because when, please, lambda equals to what? 2 at this point. Lambda equals to 2. Now, I will now say that what? I'm working on vector. This is what I'm working on. To be my vector, x1, x2, x3. Which it will be equals to what? 0 is 0 is 0. Now, with this, I've done my, the problem is half solved. The question is what? The problem is half solved. Now, the next thing I need to do, look at any convenient method of solving matrix, system of linear equation, which you can run to. If you like, you can go on inversion method, you can go on transformation method, you can go on row reduction, you can do anything to it. But me, I'm used to Gaussian elimination method, which is very, very good for me. Okay, I will just take this to what? I will call it, I will make the argument matrix, which I will be having minus 9, minus 5, I will having 3, 3, and 3, this is minus, augment it. Now, that is, I'm trying to augment it. Now, what should I do? I will have my row 3, 1 all over 3 row 3 equals to what? Row 3, which is row 3. And also, because I'm doing reduction method, which I'm trying to reduce it, it will be equals to what? Row 1. And now, it means I will do this, which will be 1, minus 1, minus 1, augment it, and I have my 7, save. Please, this statement is very, very important. When you see something like this, it means I'm reducing, row reduction. That is what it means. Not equals to, there are difference between equal and this. Please take note of that very well. Now, and don't forget, I switch row 1 to row 3. That is the name. Row 1 to row 3. Please take note of those things. They are very, very important. Now, the next thing I need to do now, this will remain my what? My tax, which is going to be what? 0. Now, with what I'm having, I'm trying to reduce. Now, I can say that what? My row 2 equals to row 2 minus 2 row 1. Minus 7 row 1. Rather, sorry. My row 3 will be equals to row 3 minus 9 row 3. Row 1 rather. Row 1. Okay, I think with the statement, I will have my I will have 1, minus 1, and 0. That will be 0 because I will be having 7, I'll be having 7, minus 7 also. Okay, minus 7 and minus 7, which I will be having, this will be 0, this and this become what? Minus, what will be minus. Hope I'm not making a mistake. I'll be having minus 2 here. Yes, I'll be having this and this. Put it plus, it will be 2, and 0 remain the way it is. Now, this time around become 9. Forget. It means I'm multiplying this by 9, 9, which they are all minus. This will be 0. This will be, that will be that is going to be plus, that will be 2. That will be 2. That will be minus 2, this is 11, and this one will be 2. Augment it. Now, can you see? I think we have done this earlier. Can you see that this and this are the same? I can say that what? 1 all over 2, row 2, and 1 all over 2, row 3. Now, which I'll be having 1 minus 1 minus 1 is 0 minus 1 1 and 0 minus 1 1. Augment it, augment it, augment it. Now that is what I'm trying to do. I can now say that what row 1, I mean row 3 minus. I can't use row 1 to reduce again because of what? It will turn back. It means I think I've got that out. I've explained that area, which I'll be having. This will be row 1 minus row 2, which is that is going to be. I'll be having I'll be having 1 minus 1 minus 1 0. Sorry, it's raining here. That is why the letter is like that. I'll be having minus 1 1 and 0. This will be 0 0 0 and 0. Now, because of this, it means I will normalize it. Take note of that. Now, what will I do? I will come to this place, which I'm having minus 1x1 plus x1 equals to 0. It means minus 1 equals to minus x2. Oh, sorry, x2. This is going to be x3. Sorry, 2 and x3. Now, since I have this, it means my x1 equals to 1. S2 equals to 1. S3 equals to 1. Now, I will now come back to the first equation, which I will have x1 minus s2 minus x3 equals to 0, which I will be having, which will be minus s2 equals to what? 2. Take note of that. S1 equals to 2. S1 equals to 2. Now, since I have my S2 equals to 2, now what will make me to, how do I do now? What should I do? It means I'll be having x1, x2, x3, which it will be equals to, what is my x1? 1. My x1 is 2, 1, and 1. Now, because of normalization, because of what we're having here, now it will now be what? Equals to 2c, c, and c. Some people, you can use any value or any coordinate, which is, if it is convenient for you. Normalize means I'll be having root of 2c squared plus c squared plus c equals to 1. Now, which I'll be having 4 plus 4c squared, 4, that will be 6c squared. 6c squared root equals to what? Equals to 1. Yes. Now, which I can square the both sides, which we are looking for no more. At this point of your life, should not be something like that. Now, it should be very good. This will be c will be equals to 1 all over root of 6. Now, please permit me to manage this side. I need to manage. Sorry. It means what I'm trying to do, the vector will be equals to 2 all over root of 6, and this will be root of 6, and this will be root of 6. That is 9. Can you see? It's very, very simple. It's very, very simple. Now you can see what is called eigenvalue and eigenvector. On the next, I think let me stop here because of that time. Time is best passing. In the next video, I'll be working on characteristics equation in details, which I'll be applying my my characteristics equation. Which don't forget that if it is 3 by 3 squared minus the trace of squared of that given matrix 1t minus cofactor of the principal diagonal. Cofactor of the principal diagonal. When we talk about trace, my trace of a given matrix is just equals to, you add up the principal diagonal. That is your trace. I think in the next video, just try to be on this. You really understand better. Don't forget to among the further solutions available. Don't forget, just try to share the video among your classmates, because this is not for elementary mathematics, among your faculty and other part of your academics. Once again, thanks for watching.